Math 3, Unit 2, Section 8. Today we're going to be talking about graphing systems of inequalities. This is something that you probably have done before, but we just are dealing with different types of graphs now, not just like two linear functions. We're going to have, quadratic functions and linear functions and exponential functions, possibly. So actually, it doesn't look like there's any exponential functions. So we're only going to be dealing with quadratics, absolute value, and linear functions. And we're trying to see, when you shade them, where they overlap. So a couple of things with graphing is that when you have your less than or greater than sign, that is a dashed line. And again, you're probably going to want maybe two different color highlighters, and then 2 or 3 different colored pens again today. So dashed line will look like this, and that just means that it's not equal to that line. Okay, where if you have the equal to, less than or equal to, or greater than or equal to, it is a solid line, and that means that the values are equal to the values on that line. Okay, so it's important to pay attention. Oftentimes you'll draw a straight line, and if it's dashed, like let's say you draw it and you know it's supposed to be dashed and you realize after the fact, well then just go through and make it look dashed like this. So just so you know, I might end up doing that too because I do make mistakes sometimes. So shading, when you're reading these values right here, less than or equal to, these mean less than. So less than means to shade below the graph. And then when you have your greater than or equal to graphs, greater than means to shade above. Okay. Also with less than, it's below, and then sometimes if it's a straight line, it's left or, down. And then greater than is above or right or up. Okay. You also can check things by checking a point. Okay, and so you could check to make sure that the point makes a true or false statement by checking those values. And so when you choose a point, though, do not choose a point, so not on the boundary lines. So the points cannot be on boundary lines. They need to be somewhere within the shaded areas. Okay, and then it says after checking the points, highlight the areas to make the true statement for all inequalities. Okay, so we're going to get started. So on this first one, I am going to say this is graph number 1, and this is going to be graph number 2 in green. Okay, so for graph number 1, and this is similar to what we've been doing the past 2 units, if we look at this function, it is a linear function, and that equation is y is less than or equal to, it's written as 5 minus x, but I like it with the x part in front, and so I'm going to rewrite this as negative x, because the negative is with the x, and then the 5 is positive, so plus 5. So now that it's written that way, my first point for my graph would be at, there's nothing in parentheses with the x, so the x value is 0, and then the y value at the end is 5. Also for this one, are we able to use slope? Your answer should be yes, because it's linear. Okay, so lines we can use slope. And so my slope for this is, if there's no value in front, it's a negative 1 over 1. So let's go ahead and plot this. So 0 on the x, up 5 on the y, make our point. And then our slope is negative 1 over 1, so down 1, right 1. And then you could go the opposite way, going positive 1, negative 1. And then I would get some sort of straight edge to draw your line, because you'd like it to be as accurate as possible. And so we're going to go ahead and draw that, and that is our first equation. Okay, so, and I would probably label this as 1 for right now, so that you remember that. And in terms of shading, so if we're looking at this line, okay, that's there, our sign is a less than sign. And so less than means we shade below. And so below is going down. Okay, if it was greater than, we would have shaded above. So I'm just going to kind of know where the shading is, and then we highlight when the two overlap. So our linear function is now done. Now we're moving on to equation 2. So looking at equation 2, that is also linear. And our graph or our equation is y is greater than 3x minus 4. This one's already in the correct form. And so one thing here, and I didn't talk about this, but this was less than or equal to, so I did draw a solid line here. But on this one that's greater than, it doesn't have the equal to sign, and so that one is going to be a dashed line, okay? I usually kind of write it out so that I don't forget. Okay, the next thing is our starting point. So 1 point on this graph is 0, -4. Again, nothing is with the x, and then -4 for the y. And this line has a slope of 3/1. So again, we get our slope from the number in front of the x, and in this case, it's 3/1. So we're going to go ahead and graph this. So we're going to go 0, -4. So 0, -1, 2, 3, 4. Mark that point. And then the slope is 3/1. So we're going up 1, 2, 3, right 1. Up 1, 2, 3, right 1. Up 1, 2, 3, oops, 1, 2, 3, right 1. And we'll go ahead and use some sort of straight edge. And then remember, this is a dashed line. So when we are drawing it, we just kind of want to make some dashed lines here. And then we can draw our arrows. And I'm going to label this as a number 2. This is greater than. So when you're looking at this line here, greater than, you shade up. And so if I shaded this way, this is actually shading down, where this one is shading up. Okay, and we can see that the two graphs intersect in this area. So this is where you would get your highlighter out, and you are highlighting the area where they intersect. The two shading parts intersect there. And then since there is intersecting area where the two lines intersect, we need to name some points that are in this area. That means that answers are going to be different for everybody. So when you're doing your homework, you probably will not have the same answers as me. Okay, and remember, the important thing is that when you're choosing a point, you can't choose a point on the line or the point that they intersect at. You have to choose a point that's just in this area. Okay, so when I'm looking at the highlighted area, the point 0, 0 is in the shaded area, and I think I'm going to choose the point 1, 0, or maybe we could do 1, 0, or that's actually at the point 0, 1. Okay, so those are 2 points that are in the highlighted area. We could check to see if that makes a true or false statement. So if we're checking the point 0, 0 to see if it makes a true statement, this is my x value and y value, and we are plugging x and y into here to see if that does make a true statement. If it's, because it should make a true statement because it's in the highlighted area. And so we're going to go here for equation 1. And so y is 0 is less than or equal to 5 minus 0. And so 0 is less than or equal to 5 minus 0 is 5. Is 0 less than or equal to 5? And that is yes. So I'm just going to put a check mark. It works out. Okay, now I'm going to go to equation 2. I'm going to use the same point to make sure that it makes a true statement. So again, y is 0, so we have 0 is greater than 3 times 0 minus 4. 3 times 0 is 0. 0 minus 4 is -4. Is 0 greater than -4? Yes, that's true. So I'm going to put a check mark, and so this does make a true statement for both. So that it's true that 0, 0 is in the double shaded area. So we're choosing a point that works. Okay, so we're going to do the same thing, and we're going to try the point 0, 1. And so with 0, 1, again, I like to label these. It's x and y. We're going to go to equation 1, and we're going to plug in these values now to make sure it still makes a true statement for both of these equations. So now y is 1 is less than or equal to 5 minus 0. So we simplify. Y is less than or equal to 5 minus 0 is 5. Is 1 less than or equal to 5? Yes, that checks out. Equation 2. Okay, y is, oh sorry, not y, 1. 1 is greater than 3 times, and then x is 0 minus 4. 1 is greater than 3 times 0 is 0, and 0 minus 4, 1 is greater than -4. Is 1 greater than -4? Yes. And so that makes a true statement. So this is just a way for us to double check that we did everything correctly. And so we chose 2 points in the shaded area. We checked those points to make sure it made true statements for both of the equations, and it did. And so we know that these 2 points work. Okay, so we're going to move on to the next equation. Okay, so again, I like to label these. That's going to be my first equation and my second equation. So my first equation, that is a linear function, and its y is less than or equal to -5. When you are graphing that, it's the line, y equals -5, but we have to do our shading. This also tells me that it's going to be a solid line. Okay, so y equals -5, we're going to go down 1, 2, 3, 4, 5. And we're going to go ahead and draw this solid line. And I'm going to label this as equation 1. And less than or equal to means means we're going to shade below or down. And so that's where we're shading for that graph. Okay, equation 2 now. That equation is a quadratic, because it has that squared term. I'm going to write this out. Y is greater than x minus 4 squared minus 1. So quadratics, we can't use slope or anything on. We'll have to plug in a point. But we can start with our vertex here. And our vertex is at 4, -1. So let's go ahead and mark that. So write 1, 2, 3, 4, -1. There's our point. We know that this graph is going up, but we're going to go ahead and pick a point. So we want to pick something to the right or to the left of this. So if we went to the right of it, that point would be like at 4, or sorry, not 4, 5. So we're going to pick the point 5 and find out what y is. So remember, we do this by, we're going to write y equals, and instead of x, I'm going to write 5 minus 4 squared minus 1. And I know I wrote equals, but we're just trying to figure out what does y equal when x is 5, okay? And so 5 minus 4 makes 1. 1 squared is 1, and 1 minus 1 equals 0. So when x is 5, y is 0. So there's a point here. We know our line of symmetry, so we're going to go across, and there's another point there. And it's curving up, and we know that it should be curving up as well, again, because our m is 1. One thing I forgot to mark here, and I did it wrong because I didn't mark it, is that this should be a dashed line. And why is it a dashed line? Because it doesn't have an equal to sign. And so I'm going to go ahead and go back and make sure that I make this look like it's a dashed line here. All right, and then this was saying greater than. So when you're dealing with greater than for this graph, greater than is going to be inside here, where less than would be the outside portion, okay? So if you look at the shading here and here, does the shading ever intersect on here? So the answer should be no. So this answer is no solution. There's no solution where these two graphs, they're highlighting intersects. And so when you're naming 2 points, there are none. So that's also a no solution. All right, we're going to go ahead and turn to the next page. Okay, so hopefully looking here, you can see that we have absolute values. So again, we're going to go ahead and label these. So this will be my first equation and my second equation. Starting with the first equation, we have its absolute value. So I'm going to go ahead and write that down. Nice thing about absolute values, we get to use slope. So we like that. Y is less than or equal to the absolute value of x minus 2 plus 1. Based on this information, my line is going to be dashed or solid. So hopefully you said solid. And my vertex for this, based on my information here, we set this equal to 0. The x value of the vertex is 2, and the y value is 1. My slope for this comes from the value in front of the absolute value, and if there isn't a value there, there's 1. So my slope is 1 over 1. Okay, we'll go ahead and plot this. So right 2 up 1, make a point, and then my slope is 1 over 1. So we're going up 1, right 1, and then across our line of symmetry. Okay, up 1, right 1, and then again across the line of symmetry. And we'll go ahead and use our straight edge and try to make an accurate graph because it helps us with our shading. We can label that as 1. Okay, less than. So this one's less than. If it had been greater than, we would shade inside here because it's going up. Greater than would be shaded inside. Less than is shaded on the outside. And so I'm just going to go ahead and kind of, we know it'll be shaded outside there for the less than value. Okay, going to our second graph. Also, it is absolute value. We have y is greater than 5 minus the absolute value of x minus 1. I don't like the way this is written, so I would flip this around. Notice that the negative is with the absolute value, so you have to keep it that way. So I still have this, so I'm going to put negative absolute value of x minus 1. And then this 5 here, it's positive, so we just do plus 5 at the end. Okay, this line is going to be solid or dashed. So it should be dashed because it doesn't have the equal to sign. The vertex, when you set this equal to 0, this vertex, the x value is at positive 1 when you set that equal to 0, and the y value is at 5. The slope on this one comes from the value in front. Since there's a negative in front of that absolute value, the slope is negative 1 over 1. So we're going to go ahead and go graph. So 1, 5, we're going to go right 1, up 1, 2, 3, 4, 5. Hope I counted that right. Okay, and then the slope is negative 1 over 1. So negative 1, we go down 1, right 1, and across our line of symmetry. Down 1, right 1, and across our line of symmetry. I'm going to go and do one more, down 1, right 1, and across our line of symmetry. Because again, we're dealing with shading, and we just want to make sure these are super accurate. So the more accurate it is, the more chances of error, or the less chance of error there is. Okay. So we have that. This was our second equation. Oh my gosh, and it's dashed. I messed up there again. Okay, so that should be a dashed line. Hopefully you guys are smarter than me and you did it dashed right the first time. Okay, and so greater than, so because this is going down, less than would have been shaded inside when it's going down, and greater than would be on the outside because all the bigger values are on the outside. So on this one, greater than, it's all the values on the outside because the bigger values are on the outside. So as I shade the outside, hopefully you notice there's actually 2 different areas that are shaded. So this area has both of the shadings where they overlap. And then this area right here also has where both of the colors of shading is overlapped. So those should be where you highlight. And then we have to name 2 points, okay? And so let's go ahead and pick a point from here. And again, you can't pick a point on the line. So I try to make sure I'm totally off the line. So let's see here, we're gonna go negative 1, 2, 3, 4, 5. Let's go ahead and do negative 6 right here. So that point is at negative, yeah, we'll do negative 6, 0. And then let's go to the other side. So if we're going 1, 2, 3, 4, 5, 6, 7, let's do 8, 8, 0. And actually I feel kind of nervous about negative 6, 0. Let's just do negative 7, 0 just to make sure I didn't like mess up when I was graphing or something. So, because the point cannot be on the boundary line. So, negative 7, 0. All right, and then we can test those points. And most of you are pretty smart. And so I think that testing is good to check your work, definitely. At some point though, you're like, I know I did everything right. This is negative 7, 0 is a point that they both intersect, and 8, 0 is also a point. But so we might not continue checking on all the rest of them, but let's just go ahead and check one more time for these ones. So for the point, negative 7, 0, this is my x, this is my y. We're going to have to check it on both equations. In order for it to be a point, it has to work on both equations. So we're going to plug an x and y into this equation. we get 0 is less than or equal to absolute value of negative 7 minus 2, plus 1. So I just plugged in my x and y here. Negative 7 minus 2 is negative 9. So now we have 0 is less than or equal to, the absolute value of negative 9 is 9, and then you have 9 plus 1. So 0 is less than or equal to 10. Is that true? It is. It checks out. Equation 2, same thing. Now I'm going here to equation 2, plugging in the x and y values. So 0 is greater than 5 minus the absolute value of negative 7 minus 1. So negative 7 minus 1 is negative 8. 0 is greater than 5 minus, and the absolute value of negative 8 is positive 8. And then 5 minus 8 is negative 3. Is 0 greater than negative 3? And that is yes, it's true. So that works. Okay, so this point does work for both of those. Okay, let's go ahead and try the next point now, which was 8, 0. And so we're going to go back to equation 1. We're going to plug in x and y for 8, 0. So we have 0 is less than or equal to, the absolute value of 8 minus 2 plus 1. Okay, so again, just plugging that information in. 0 is less than or equal to 8 minus 2 is 6, and the absolute value of 6 is 6, and 6 plus 1 is 7. 0 is less than or equal to 7. That is true. Okay, checks out. Going to the second equation. Okay, and so again, plugging in these x and y values. 0 is greater than 5 minus the absolute value of 8 minus 1. What is 8 minus 1? 7. So 0 is greater than 5 minus, and the absolute value of 7 is 7. And 0 is greater than 5 minus 7 is negative 2. And 0 is greater than negative 2. That works out. And so this is also a true statement. All right. So next one, you'll notice this one, actually, I guess I lied at the beginning. There is some exponential functions. This one has 3 different functions. So we're going to want 3 colors. So this will be equation 1. This will be equation 2. And then this blue will be equation 3. Okay, starting with equation 1. Equation 1 is linear. It is y is greater than 1, which means it will be what type of graph? What type of line? It's going to be a dashed line at y equals 1. So y equals 1, going right here, we're going to go ahead and make this a dashed line. You can label that as 1. Greater than, the bigger values, the greater than values shade up. Okay. Equation 2. 2 is exponential. Our function is y is less than or equal to 3 to the x power. Okay, all exponential functions, if we were to plug in 0 for x, 3 to the 0 equals 1, so the y value would be 1. So a point on this is 0, 1. So we're going to go 0 up 1, we're going to make that point there. Okay, now we're going to plug in a point to the right of this. Okay, we also know that this has like an asymptote at 0. And so I'm just going to kind of draw like a little dash line here to remind us that this point doesn't go below that dash line. Okay, and so we're going to plug in like 1 or 2. I'll plug in 1. Okay, so when I plug in 1 for x, 3 to the first power makes 3. So this is a 3. So at 1, it goes up 1, 2, 3. Okay, we could also plug in 2 if we just want to be more accurate. If you plug in 2 for x, 3 to the second power makes 9. So at 2, it goes up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then this, because it has the equal to sign, is a solid line. So we're going to go ahead and draw this. Remember, it doesn't go below 0. It's a solid line, and we've graphed it. Okay, less than or equal to. So the greater than portion would be shading up, which would be here. The less than is on the outside, where all the negative values and stuff are. So less than is shaded out here. We'll lightly do that in green. So as of right now, we can see that it's shading It's double shaded in this area, but we have to see where it's triple shaded, where all three graphs are. So 3. We have y is greater than or equal to negative 2x minus 1. This is linear. Our first starting point is going to be at 0 because nothing's in parentheses with the x, so 0 for the x, and then negative 1 for the y. Our slope is always the value in front of the x, which is negative 2 over 1. So 0 on the x, negative 1 on the y, and then negative 2 over 1 for our slope, negative 2, right 1, negative 2, right 1. And we can do the opposite, up 1, 2, left 1. Oops, I did something wrong. Oh, no, that's right, just kidding. Okay, and so then we will go ahead and draw our line. And this one should be solid because it has that equal to sign there. So we'll go ahead and draw our solid line. And then greater than would be shading up. So on this one, up is over here, down would be over here. So we shade that. And hopefully you can see that the graphs overlap from here, or the shading overlaps from here to here. Okay, and so a couple points in the area, again, you want to make sure that it's easy that it's there, it's not on a line. So I'm going to go over like 1, 2, 3, 4, up 1, 2, 3. So let's just say like 4, 3 would be 1. You could even do like 5, 3 is 1, 6, 3 is 1. There's lots of points we could go if you wanted to be 5, 4. So going right 5 up 1, 2, 3, 4, that's definitely in the shaded area. So you just have to name 2 points that would for sure be in that shaded area. And I've already showed you how to check it. And for time's sake, we're not going to check it today, or I'm not going to check those points. Okay, last one. We're going to go ahead and do here. This one is only 2 equations. So that's going to be our equation 1. This is equation 2. Starting with equation 1, that is an absolute value. The equation is y is less than or equal to absolute value of x minus 2. Based on the fact that this has an equal to sign, we know that it will be a solid line. Next, our vertex. There is nothing inside with the absolute value with the x, so that means the x value is 0. The y value is negative 2. Since there is no value in front of the absolute value there, we know there's a 1, and so our slope is 1 over 1. So we'll go ahead and plot this. 0 and then negative 2. And from there we're going to go up 1, right 1, and then our line of symmetry. Again, up 1, right 1, our line of symmetry. And we'll go ahead and draw our line and hope that we're making this accurate. Okay, next we shade, and so because this one's less than is going to shade below. Okay, next graph, number 2, we have y is greater than or equal to 2x squared minus 5. I forgot to write, but based on that there is a squared term, this is a quadratic. For the quadratic, there is nothing in parentheses with the x here, okay? It's just x squared, so that means the x value of our vertex is 0, and the y value is negative 5. Based on the fact that that has an equal to sign, that means it is a solid line. And then we can't use slope because it's quadratic, so we're going to go ahead and plot our vertex. So 0, negative 5, we're going to go down 1, 2, 3, 4, 5. And then we can choose a value to the right or left of that. So I'm going to go ahead and choose a point to the right. So I'm going to choose 1. So we're going to plug it in here and then find what y equals. So y equals 2 to the 1 squared minus 5. 1 squared is 1, and 2 times 1 is 2, and 2 minus 5 equals negative 3. So when x is 1, y is negative 3. So we go down 1, sorry. So we're going right 1, down 1, 2, 3, and then across our line of symmetry. For accuracy, I might go ahead and choose another point. So let's go ahead and plug in for 2 and find out what that equals. So again, we'd have y equals 2, and then I'm plugging in 2 for x, 2 squared minus 5. 2 squared is 4, and 2 times 4 is 8, and 8 minus 5 equals 3. So at 2, y is 3, so we're going to go right 2, up 1, 2, 3, and then across our line of symmetry, and then we can go ahead and accurately draw that quadratic function. And this is greater than, and since it's curving up, our greater than values are the parts that are inside here. Less than would be like the negatives that end up being on the outside. So greater than, you shade here on the inside, and you can see that the only place it overlaps is this little piece here in the middle. So we have to name 2 points. It cannot be points on either one of the lines. So it makes it a little bit more difficult. That 1 point I can tell for sure is 0 and -1, -2, -3. And then it also looks at another one that's really easy would be 0 and then -1, 2, 3, 4. 0, -4. So I'd probably choose those just to be safe. And that's it.